Hi everyone, my name is Haley Metzger, and this week I'll be going over problem number 4 on the Forces 1 Expert TA homework. So the objectives of this problem were using this picture that we were given here, draw a force body diagram for the block of mass, and then write the net force equations for the x and y directions using that free body diagram. So here is the original picture we were given. We have a block of mass M with two forces shown acting on it. We have force 1 that's pushing to the left, and then we have force 2 that's pushing to the right and down. So then we move down here and we draw the free body diagram. In the first two forces I drew were the force of gravity, which is pushing down, and then the normal force, which is perpendicular to the force of gravity pushing up, and the block of mass is sitting on a flat surface, which is why the normal force is directly perpendicular to force of gravity. And then you'll notice that I drew F1 to the left and then force 2 down and to the right, and I did the angle theta to show that. And then I also defined the positive x and y direction. So the positive x direction for this is going to be right, and the positive y direction is going to be up. And then the next thing that we had to do was find the net force in the x direction. So to do that, I first decided which forces were in the x direction, and that was going to be force 1 and force 2. So because force 2 is pointing to the right, which is the positive direction, I knew that it was going to come first in the net force equation. But I had to take into account that force 2 has x and y components because it is being pushed at an angle, and I just needed the x component of this force. So I used cosine theta because cosine is adjacent over hypotenuse, and this adjacent side is what would be the x component of F2. So the net force equation in the x direction is going to be F2 cosine theta minus F1 because F1 is pointing in the negative direction, so it is going to be negative. And then for the net force equation in the y direction, I had to determine which forces were in the y direction. So that was going to be the normal force, the force of gravity, and then the y component of force 2. And because we defined up as the positive direction, I started the equation with normal force and then subtracted the force of gravity from that, and then also subtracted F2 sine theta. I used sine because if you remember, sine is opposite over hypotenuse. And if you look at this angle, the opposite component of the force is what would be in the y direction. So that is how I got F net in the y direction equals normal force minus force of gravity minus F2 times sine theta. And then some pitfalls when doing this problem. You need to make sure that you define your positive x and y directions before you start writing equations, because that's something that you could really get confused on if you did not have those defined. And also, you need to make sure that you're using sine and cosine properly in these equations, knowing that you're using cosine for the x direction and sine for the y direction. And yeah, that is really all. As long as you remember those things, you shouldn't have too many issues. So, thank you.